Hello and welcome to the University of Manitoba Resources for Agricultural Engineering podcast. I am your host, Uduak Edet, an agricultural research extension engineer in the Department of Biosystem Engineering. This podcast is your gateway to discovering the latest innovation, research, and practical solutions in agricultural engineering. Our mission is to forge meaningful connections with the agricultural community and help farmers address their engineering needs and aspirations. Today, I am joined by Vincent Hervet, who is the research scientist, Stored Product Entomology at Agriculture and Agri-Food Canada in Manitoba. Before we discuss insect management in grain storage, please tell us about yourself and what inspired you to study insects.
Hello, Uduak. Thank you. Yes, that's a very good question. So I grew up in France, in the middle of the country on a farm, and where I grew up, there was a lot of insects around when I was a little kid, and I never paid them too much attention, to be honest, until one day when I was 6 years old, I found this beautiful butterfly. It's the old world swallowtail, big yellow butterfly, which landed on a rose in front of my the house where I grew up, and I caught it with my hand. It was so big I could hardly handle it. Then I called my mom to put it in a jar, which I did, and then I fed it flowers for several days and observed it, and eventually it died. And I didn't want to part with it because it was so beautiful. So then my mom told me some people pin insects, and keep them. Maybe you can do that. So I did that. And then I was looking for more butterflies, catching them, always trying to keep them alive as long as possible. And then I extended to other insects, always observing them, feeding them as much as I could, learning as much as I could, buying all sorts of entomology books. So a lot of my early exposure to entomology was just personal interest. And eventually, because I was very interested in entomology, that's when I pursued a master's and PhD in the field of entomology. So I studied parasitoids of crop pests primarily, and other aspects of crop pest control, integrated pest management. And that was conducted here in Lethbridge, in Alberta, with the research center over there, Agriculture and Agri-Food Canada, and with the
Okay.
University of Lethbridge. And when it was time to look for a job, I applied to one in grain protection, and entomology of stored grain and other stored products. So stored product is any stored food. And so I
Oh,
got the job. So that's what got me into this initially personal interest and then need for a job. And it's great to be able to match both.
okay, thank you. Thank you. Good to know that you've actually use your childhood this and transfer it to build it as a career, and that's good to hear. I'm just wondering, um why is insect monitoring in stored grains such an important topic?
Yeah, so insects in stored grain bin are very tiny. So they're so tiny, they will actually be able to travel between the grain kernels, most species, and fairly fast. And so they are so tiny and they are so insidious, and they develop very fast, and they can very quickly destroy the grain without you knowing it because they're so tiny you can't really see it. For example, the most important pest of stored grain in Canada is the rusty grain beetle. It has an average of 2 millimeter long. It's a tiny little brown beetle. And it has the habit of degerming seeds. So it goes from one seed, basically they germinate, and then it will degerm a whole bunch of seeds. And you don't see it because the seeds have a pinhole. So what might look like good seeds is in fact dead seeds. So the problem with this particular beetle, so the rusty grain beetle is 95% of the insect detections in elevators in Canada. So I will primarily talk about this species because it's by far the main pest of stored grain. So the
Okay.
problem with it is once it degerms a seed, so all the seed producers will have seeds that don't germinate. Actually, I've talked to some of them, and in fact, seed farmers tend to hold seeds in their grain bins longer than other farmers, and that is a huge problem with the rusty grain beetle, because the rusty grain beetle will, over time, be able to develop into such numbers that it will damage a whole bunch of seeds. So those seeds won't germinate once they're planted. But even the seeds that are kept for human or animal consumption, when it's degermed, then it starts to decay basically. Then it starts
Okay.
to some natural processes occur in the seed that degrades its internal quality. So free fatty acids are produced and it gets rancid more quicker. So that's why we don't want the seed to die too early or
Okay.
before we process it. So we don't see them. So that's why it's important to know that the insects are there and to do something about that to prevent them from proliferating in the grain bins.
Okay. Okay. So how does this affect food security and global grain markets?
Yeah. So in Canada, because we enjoy a lot of cold weather, particularly here on the prairies, it's not as bad as in other countries. But globally, about one third of the grain produced is destroyed during storage. I mean, the estimates vary widely. And the reason is because we don't really know what the losses are in farms. It's very difficult to know that. So I've seen a huge range of estimates. I think one third is pretty conservative. Um, so yeah, globally, that's what we're looking at: huge losses on farm. So that's why, and not just on farm, but primarily on farm. So that's why it's so important to be able to manage those insects, and not just insects, the mold as well, to make sure the grain is kept under ideal conditions. Otherwise, it's a huge loss.
Okay. Okay. So when you talk about um, grain insect infestation, does it affect all grain or there's specific type of grain that insects tends to um, focus more on?
Yeah, and that's a very good question. And indeed, not all grains are affected the same. Cereals are by far the most impacted by insects during storage. So I conducted a study where I put traps in various grain bins and looked for insects. So what I found is in Canada, pulses are virtually not affected by insects during storage. I say in Canada because if you go to tropical countries, you have the so-called brookids or the bean weevils, which are very important. They damage pulses a lot. But in Canada, it's it's extremely rare. We do have the bean weevil. It's extremely rare. Overall, not a problem. If you have pulses in grain bean, you're pretty guaranteed you won't have any insect.
Okay.
Everything that is oil seed as well. Extremely rare to have insect problems in oil seeds. What I found from personal observations is many insects will feed on the oil seed, but it will take them a very, very, very long time to develop and multiply, such so that during the storage time, which is usually less than a year in Canada, it's just not a meaningful impact. So the
Okay.
real problem in Canada is really cereals. So that's where we find the largest diversity of insects and also they develop the fastest. So that's where we really need to keep an eye.
Okay. Okay. So with this insects infestation, what are the traditional methods actually used to monitor insects in grain storage?
So the traditional method is to not monitor, unfortunately. uh, the problem is it's very time consuming. Farmers and other people, they have so many other things to do. It's one more thing. And I mean, understandably so, you will have to actually climb into the grain bin, put the trap in it. The trap is a tube with holes all around and a little insect reservoir at the bottom. So you push it into the grain, then you wait a certain amount of time, 2 weeks, 1 month, then you retrieve the trap. You look what insects are in there, and you kind of have an idea whether you have an infestation or not. You look if there's many insects or not many insects. So there's also the safety aspect. You do have to climb up the grain bin and climb down with the trap. Um, so that's a problem. So I mean, those traps are available. Another problem is it's not super cheap. If you were to put some in all the bins, there will be a lot of time spent, and it will be a little bit expensive. So that's why people typically don't do it. It's pretty rare, but otherwise, those so-called probe traps are the way to monitor insects in grain bin. So there is also an electronic trap that exists. It's called Insector. It has a little laser at the bottom that detects the insects that fall into the trap.
Okay.
And there is a software that analyzes this. So you don't have to go into the grain bin with this, but this system is very expensive. Um, so yeah, those are the main problems why people don't monitor grain in grain bins.
Okay. Okay. So are these method effective, or is there any other technology that you think might actually monitor or detect insects better than the ones you've mentioned?
Yeah, so it is effective in a way, although we don't have any baseline numbers. So if you see a few insects, is it a big problem? It's not a big problem. It's very subjective, and some studies have tried to assess, what number is significant. But there are so many different parameters at play that it's not conclusive. So basically, right now, so that's one of the problem. We don't really know, so it's not super effective for that. If you see a whole bunch of insects in the trap, then you know you got problem, and if you see virtually none, you know you don't get problem. Other than that, in the future, if there were electronic systems that were cheaper than the ones currently in the market I just talked about, that will be a lot more efficient. So we are not there yet. So I believe that progress needs to be made to improve the efficiency for monitoring insects in grain bin, and I think it will come.
Okay. You mentioned one thing which is about putting the probe inside the grain bin itself. Is there a specific location that farmers should focus on when placing those probes?
Yeah, very good question. Once again, once again, sorry. So the best location is at the very tippy top of the inverted cone, at the top of the grain mass. So I guess there's two reasons for that. One is many insects tend to climb. Um, if you put something high, they will tend to go up there. So you do find more insects for this reason. Another reason is it tends to be moister and warmer here at the top of the cone. And when you aerate the grain to try to dry it or cool it down, it starts at the bottom, and the last bit of the grain that dries or cools down is the top of the cone, the very tippy top of the grain mass. And so the insects like it when it's warm and moist, and so they tend to be there. So if you want, and usually hotspot tend to develop there as well. So that's why it's important to monitor there. So if you can put a trap anywhere in the grain bin, the top of the cone is always the best place to spot the insects.
Okay, okay. Are there any regulation or industry standard for actually um, monitoring insects in store grain?
There is no regulation or industry standards for monitoring insects. However, the Canada Grain Act stipulates that it is forbidden to sell or buy grain that possesses at least one live grain pest in it. So when a farmer goes to the elevator to sell the grain, they take a sample, and if there is at least one live grain pest in there, they are not allowed to accept this grain. So there is no regulation for monitoring the insects, but there is regulation for not having any live insect in the grain.
Okay, okay. Now, there's this buzzword about AI and artificial intelligence, machine learning. Do you think it has any role to play in terms of insect monitoring in grain storage?
Yeah, I think so. Like if we could more efficiently detect insect infestations, then we would know when it's time to do something. Because the more you wait, the worse the problem, and then the harder it is to control the problem, and also the more expensive it is. And artificial intelligence or machine learning could very well be one of these ways to help. Could be either at the farm, could be at the grain elevator in the grain they receive, could be in industries, mills. Yes, most definitely. And it is something that researchers are looking into right now. So hopefully in a few years we'll see something about that.
Okay, okay. Thank you. Um, what role does temperature, humidity, and even the bean size, what role do they play in terms of the insect activity within the grain bin itself?
Okay, so we know that the higher the humidity and the higher the temperature, the faster both molds and insects proliferate in grain. Actually, there are a number of graphs for safe storage guidelines on the Canadian Grain Commission website. These are for for grain spoilage. So, what is the safe zone in terms of temperature and moisture content to prevent spoilage during storage? These work very well with mold, but that said, they also work very well with insects. If you can keep the grain within those safe storage guidelines, the grain should be free of both mold and insect. The only difference with insect is nearly all species of grain insects will stop multiplying and developing below 18 degrees Celsius. A few of them will still develop and multiply down to 15 degrees Celsius. So if you can bring the grain down to below 18 degrees Celsius, you will basically stop any insect infestation. So that's why it's important to decrease grain temperature as early as possible, and then it will be safe from insects below those temperatures. Oh, the size of grain bin. Okay, so I did a study again, a survey across the prairie provinces of Canada to look at insects in grain bin, and I did notice a trend related to bin size. Almost inevitably, the larger grain bins had less insect problems, but they also had better grain quality in terms of moisture content and temperature. So bigger grain bins resulted with less insect problem, but I think this is because those bigger grain bins tended to be more modern, often were equipped with temperature cables, and were better managed. I think that's why. I don't think it's the size of the grain bin per se that made a difference. I think the difference is the way people manage bigger grain bin as opposed to older, smaller grain bin, which may have a wood floor or which may not be aerated. So that's where
Okay.
the difference is.
So what's kind of like the biggest challenge in detecting or controlling insect population in grain storage?
I think the biggest problem is farmers are just too busy to deploy traps, monitor traps. And as I mentioned, the traps are the most efficient when you put them at the very tippy top of the grain mass. You actually have to climb all the way to the top of the grain. It's very challenging. It's not easy. So I think that is the biggest challenge when it comes to monitoring insect populations. Um, so again, if there was some kind of electronically know there were insects, that will solve this problem.
Oh, okay, okay. You know, we look at Winnipeg, especially with this last with this current winter. You notice the way the temperature fluctuation, like it goes very low and it goes high, and people are talking about climate change. Um, do you think there's any, as in, have you observed any shift in terms of the insect's behavior with this recent change in terms of the weather?
Okay. So it's hard to know because there hasn't been a survey before the one I did across the prairies or across Canada for this matter, looking at insects in grain bin. So if we don't have a baseline, it's hard to know what you see, if it's normal or not. I think
Okay,
it is normal what I saw because only insects that were well known, and the insects that were the most known, like the rusty grain beetles, were the ones I found the most primarily. So I don't think that we see an impact of climate change. I did not collect any new species. Actually, that was part of the rationale why I did this work was, maybe these new species moving into Canada from the south, but I did not find any so far. So it's maybe early days. There definitely are species in the United States that definitely don't like cold too much. And if global temperatures were to increase by a couple degrees, we most likely find them here. So it's probably a matter of time, and we're not there yet, I would say.
okay, okay. You talked about um, conducting a survey, conducting a research. Can you kind of give an overview of what's the research is all about?
Um, research in grain storage.
Yes.
Okay. So I work on three different things mainly. So the detection of insects, the prevention of insects in stored grain, and the control if you can do
Okay.
anything. So I guess the survey that I conducted, putting traps in grain bins, this goes into detection. So that's one project that I'm currently working on. I'm also doing some work on the use of temperatures to control insects. So all grain insects will develop the best between 20 and 35 degrees Celsius. Above or below this temperature, they will stop not developing as fast, and further above or below, they will start to die.
Okay.
So I've looked at how we can use cold temperature to control insects in grain, particularly the bean weevil, because there was some trade implications with the bean weevil. Some countries that buy a lot of Canadian bean had quarantines on that bean weevil, and that was a problem.
Okay.
Um, so right now, yeah, and I have a third project also right now, which is um, how we can use beneficial insects like parasitoids to control grain pests in facilities. So those insects will go and target the pest and kill them, so you don't have to do anything. It's just natural control.
Okay. Okay. So based on the research you've done so far, what advice can you give to farmers?
Okay, so primarily from my survey of insects in grain bins across the prairie provinces, and also I did measure grain moisture content, temperature, and also when the grain was harvested and where the fans ran to aerate the grain and these kind of questions. And one thing I noticed, well, there's many things I noticed. One thing was the fall, when the years that have higher temperature during the fall, we see more problems. The grain quality is lower, there's more insect problems, there's more mold feeders. So I found a lot of mold feeders, which only feed on mold, not on grain. And some beans have very high number of those. So that tells you that grain quality is not optimal because that means there's mold or there has been mold that started to
Yeah.
develop. So yeah, fall temperature is one thing. Another thing I noticed is people don't always aerate the grain right away. They wait for the temperature to cool down, to cool down the grain. But um, there are two things we can act upon: it's temperature, but there's also the moisture content, and
Mhm.
you can regulate any of these. So after harvest, if the temperatures are still too high to cool down the grain, one thing that can be done is dry it. And one thing is the higher the temperature, the faster the grain will dry. It's because the molecules move faster, so then they dry faster. So
Mm.
immediately after harvest, I will recommend to turn on the fan to try to dry the grain. If you wait too long, if the fall temperatures are too high, the grain is going to start to spoil. Another thing is during the night or early morning, oftentimes the temperatures are low enough at the end of the summer or early fall to cool down the grain. So we don't have to wait for the outside temperature to be very low to start cooling down the grain. The earlier, the better. Consistently, I found that the people who waited too long, usually the grain quality had already gone down, and
Okay.
usually the insects were already in high number, and usually there were a lot of mold feeders. So yeah, turn on the fan the earlier the better, to dry the grain, to cool down the grain. Another thing I noticed is people don't seem to really know how to handle the grain during the summer. If the grain is so most of the grain is sold during the winter month, and that's good because it's cold and nothing really happened. But if the grain is kept during the summer, uh, problem is it can warm up and then you have problems of mold and insects and you don't have cold temperature to stop all of that. So what do you do? So again, based from observations of what different people do, it seems that if the grain is really cold during the winter, you turn on the fan during the winter, you cool it down below 0 degrees Celsius, like -10 or something,
Mm-hmm.
this grain will remain below degree Celsius the whole summer because
Oh.
it has such high insulating property. Grain is a very, very good at insulating, right? So if you
Mm-hmm.
don't touch it, it will remain cold. And at these temperatures, insects will not be able to develop, and mold will not be able to develop either. 4 degrees
Okay.
Celsius is the limit at which many molds can no longer develop. So it's good to keep the grain below 4 degrees Celsius. So I would recommend, however, to monitor the moisture content at the top of the grain mass, because if you have a whole bunch of cold grain and it's hot outside and moist, there is a risk that the top of the grain mass might suffer from condensation. I did not
Yes.
notice that. Interestingly, I did not notice that. The people who kept the cold grain throughout the summer came fall, it was still good, and there was no excess moisture at the top. So that's a very interesting observation. But regardless, I would still advise farmers to monitor in case there is excess moisture accumulation at the top. And if that's the case, I would recommend moving the grain into another grain bin, turning it over to another grain bin to
Yeah.
homogenize those moisture content and temperature gradients. So
O-
those will be my main advices.
Okay. Okay. Um, what role does maybe engineering or agriculture engineers can actually assist you in helping you manage insects in store grains?
One thing, so yeah, I work at the University of Manitoba, so I collaborate with engineers here in the Department of Biosystems Engineering. So one thing that we can help each other on is to develop those so-called sensors. Actually, I work with Dr. Fujijian, and so he has a project to develop sensors to detect insect in grain. So there's different ways we can detect insect in grain. Some people have used sound, vibration created by insects feeding on the grain. Other people have looked at the increase of CO2. Um, or there is a number of other things we can look at. Actually, I don't want to say too much about this particular project because I don't know how sensitive it is. And
Yeah.
since I'm not the main PI on it, it's Dr. Jian. But I would just say that, yeah, he's working on development of sensors that, if it works, it could potentially revolutionize the way that insects are monitored in grain bin. Another
Okay.
thing is to look at population dynamics. Many engineers are also modelers, so they can develop models. So if we look at certain conditions, grain, temperature, type of grain, moisture content, and so on, and the insects that are out there, then you would know how long it will take for a certain species to multiply in the grain, and whether your grain is safe or not, or if you need to do something. So, or anything that's related to grain management. Other things that my predecessors have found, if you use an auger or a grain vac for this instance, you can kill the vast majority of insects in grain, nearly 100%, in fact, especially in
Oh,
the case of
interesting.
grain vac. Yeah, because of the insects are fairly squishy if you think of it, and fairly fragile. So it was found that the augers will kill nearly all insects that are outside the grain, just, by being carried throughout the auger, they just get crushed. Remain the insect inside the grain. And it was found that grain vacs, especially if there is a 90-degree angle in the pipe and you don't suck up too much grain at once, that these seeds will impact onto that angle, and that will kill virtually 100% of all the insects, whether they are inside or outside the grain. But the grain has to be fairly dry, I have to mention. It was found that
Okay.
if the grain
Okay.
is not sufficiently dry, it doesn't work too well. So things like this.
Okay. Okay. Um, for listeners interested in the technical side of the work you've done, could you explain some of the data analysis or modeling technique that you use in your research?
Yeah, I can mention one interesting analysis is the probit analysis. So this is an analysis we use to confidently extrapolate a set of data, for example. So when I work with temperature, so we look at how long it takes for an insect to die at a specific temperature. And we can look at multiple temperature, but we can't look at every single temperature, that will take too long. And
Yes.
so if we have a few different temperature and we know um, the rate of death for each temperature, we can analyze with the probability analysis, and it does a very good job at extrapolating to give a good confidence interval of how long it will take the insects to die at different temperatures,
Yes.
those you haven't tested.
Yes.
It can also be used to, so I used it to see how long it will take an insect to die at a certain temperature, like the bean weevil at -5 degrees Celsius is the
Okay.
temperature we used. So we looked at LT50, so that's lethal time, where you get 50% of mortality, and then LT95. But to get the LT100 is very difficult because you have to do this experiment a very long time, and usually you don't have enough insects to get the numbers you need to get that 0.000001. You need a
Yeah.
lot of insects. So we use the probit analysis to extrapolate those data to see where we
Okay.
get the 100% control at certain temperature, for example. Yeah, so
Okay.
probit analysis, a very interesting analysis, is very useful.
Oh, okay. That's good to know. Looking ahead, what emerging trend or research area in insect most monitoring are you most excited about?
Yeah, to me, it's all the AI. At first, I wasn't too convinced because of the cost involved. Because if we were to develop, a sensor that it can detect all the insects, but then you look at the cost, like, oh, okay, it's prohibitive. It's not gonna work. Nobody's gonna buy it. However, we've seen with modern technology, like for example, the sequencing of molecular sequencing of DNA, like it started just a few, like 20 years ago, was tens of thousands of dollars to do some kind of
Oh,
sequencing. Now it's like 0.0, $1 for one sample. So the cost has gone dramatically down.
yeah.
And it seems to be the case with many of these new technologies. So I think this is, I think, is what is exciting. We can develop sensors. Maybe right now the cost will be too prohibitive, but if the technology is there, and after a certain number of years, once the technology, when it's easier to produce it, there should be a price decrease that make it possible for farmers to buy, and then they would know in real time what the insect situation is in their grain bin.
Okay, okay. Is this where you see the future of insect monitoring going in the next 5 or 10 years, or it's going to go a different direction from AI?
Um, I think the traps I previously mentioned, the probe trap where you have to climb the grain bin, putting it in there. Those have existed for a long time, and people don't use them. It's simple, but it's just too much work. So I don't think that's the future. I think the future is something like the sensors that are on cables in grain bins. So right now we have temperature sensors primarily.
Okay,
Um, but you can also have a moisture sensor, and sometimes you even have CO2 sensor. And in fact, a rise in CO2 is the very first indication that you have organisms developing in your grain. Could be mold, could be insect. So I think this is the future. Whether it's CO2 sensor or other sensors, I do think that's where I see the future going. Like something incorporated with those cables, with those sensors to detect more things, such as insects.
okay, okay. So on a general note, what resources would you recommend for farmers or storage managers looking to improve their insect management practice?
The main thing I would recommend, and the first thing I always recommend, is those safe storage guideline graphs on the Canadian Grain Commission. And it shows very clearly which temperature and which moisture content the grain will spoil or not spoil. That's very useful. Um, but on this website, there are many other things. It's not just that. If you look at managing grain, you will see how to prevent insect infestation or spoilage, how to disinfect grain bins, how. So this is available. It's already there. It's on the website. So that's the main thing that I would advise people to check if they want to improve grain management. There's many other things I could mention, but I think it will take too long, and I think it's too detailed. While this, I think, is big picture. It's readily available. It's very useful. So I will direct people to this website.
Okay, thank you. Is there anything else you'd like to share about insect management in grain storage?
We've already talked about various aspects of it. Yeah, keep the grain cool and dry, and then you won't have any problem. Oh yeah, one thing I should mention is it's impossible to prevent insects from entering the grain bin. The insects are so tiny, and the grain bins are not hermetic, which means you cannot stop them from entering. They will enter. I guarantee you, if you were to check every grain bin in much detail, you will find insects in every single one. The goal is not to stop them from entering, the goal is stop them from multiplying. And you do this by keeping the grain temperature and moisture content low. Yeah.
Okay. Thank you so much, Mr. Vincent. It's been a pleasure meeting you and learning more about your experience with insect management in grain storage. We're certainly looking forward to hearing more about your research and experience. Thank you all for listening, and please stay tuned for more upcoming podcasts on the University of Manitoba's resources for agricultural engineering, your gateway to discovering the latest innovation, research, and practical solutions in agricultural engineering.